All right, geometry. Here's some problems involving perimeters and areas of similar figures. All right. So the first question: the triangle on the right is a scaled copy of the triangle on the left. Identify the scale factor. Express your answer in simplest form. So this is a one-way scale factor problem. We want to know what is the scale factor going from the triangle on the left to the triangle on the right. What's that scale factor? Well, we are going from a bigger triangle to a smaller triangle. This is called a reduction, or we are reducing. Okay. Now, it's a safe bet if you want to find the scale factor, right? You always put the image length over the pre-image. Now, back in chapter 7, I didn't really care. Either way was fine, but there's a specific order for this problem. So you'll be wrong if you do it the other way. So in this problem here, obviously this 6 and this 21 are corresponding lengths of these similar figures. So we're going to put 6, which is for the new figure, the image, and then 21 in the bottom for the pre-image. Now we do have to reduce this. You cannot divide. You can't use decimals. So if we divide both of these by 3, because they're both divisible by 3, the answer here should be 2/7. Notice that when you're reducing, you're going from big to small, so your scale factor should be less than 1, and 2/7 is definitely less than 1. So the answer here is 2/7. So this is more or less a review problem for you. But again, getting your mindset into scale factor again is very important. There we go. Okay, let's do another problem. All right, so here's the next problem we're going to do. It says the right triangle below is dilated by a scale factor of 1/3. Find the perimeter and area of the right triangle below, as well as the perimeter and area of the dilated right triangle. Figures are not necessarily drawn to scale. So again, we talked about dilations being, this idea of similarity, right? That you're enlarging or reducing a figure. So we are reducing this larger right triangle because the scale factor is 1/3 less than 1, right? So here's your scale factor. So your scale factor is 1/3. So there are a couple ways to do this. First thing, and this is kind of the old school way, chapter 7, is you can actually take 1/3 of each of these dimensions and you get the new dimensions. So I'm not going to do that right away. We'll do that to check. All right. The way that I want you to do it is by using the new ideas. The fact that the perimeter of the image over the perimeter of the pre-image equals the scale factor. And the area of the image over the area of the preimage equals the scale factor squared. These are the ideas I want to use here. So first thing I'll do is I'll find the perimeter of this triangle. So I'll do it right here. So the perimeter of the image, the perimeter of the preimage. Let me erase that real fast. Eraser. Here. So the perimeter of the original figure, the preimage, is going to be 21 plus 72 plus 75. And if we add that together, that's 147, 168, I do believe. Let me just double check. Yeah, 168. So that's the perimeter of the given triangle, 168. So now, to find the perimeter of the dilated triangle, we're going to come over here. And again, remember, if you want to find the perimeter of the image, if you multiply both sides by the perimeter of the preimage, there you go. The perimeter of the image is the scale factor times the perimeter of the preimage. So we're simply going to take 1/3 and multiply by the perimeter of the original figure, 168. We're going to take 1/3 of that original figure's perimeter. And 1/3 of 168 is 56. So without even knowing anything about the lengths of the other right triangle, I was able to find, not there, I was able to find its perimeter right there. We'll do the same thing with the area, or a similar thing, right? So the area, and I'll use blue. So the area of the preimage is going to be 1/2 the base times the height. So that's 1/2 of 72 times 21. That's 36 times 21. That's 756. So that is the area of the preimage, the original figure, 756. So now to find the area of our image, this new smaller right triangle, again, multiply by the area of the preimage. And to find the area of the image, you're going to take the scale factor squared and multiply by the area of the pre-image. So the scale factor squared would be 1/3 squared times 756. 1/3 squared is actually 1 squared, which is 1, and 3 squared, which is 9. So we're taking 1/9 of 756. And that comes out to be 84. And now, just to double check, and I'll do this in green. If I have green, I like green. Yes, I do. Now, let's actually take the dimensions and multiply them each by 1/3. So let's times that by 1/3. 21 times 1/3 is 7. Let's multiply 72 by 1/3. 1/3 of 72 is 24. And let's multiply 75 times 1/3. That's 25. And now, if we want to find the perimeter of this image, we add 7, 24, and 25. Well, that's 49 and 7, which is 56. Boom, that's correct. If I want to find the area of this image, I'm going to take 1/2 the base times the height. That's 1/2 of 24 times 7. Half of 24 is 12. 12 times 7 is 84. And that's right. So I know I'm right. Okay. So again, this problem gives you the luxury of doing it the new way, which I hope you practice, which is over here, right? Or doing it sort of the old way by finding the new dimensions and then find the perimeter area that way. Either way, you'll be right, but try to practice this new idea. Great. There we go. Okay. Next problem coming. I think I got a couple more. Okay, so this one says the rectangle below is the image of a rectangle that was dilated by a scale factor of 3/4. Find the area of the pre-image, the original rectangle before its dilation. Figures are not necessarily drawn to scale. So again, this is sort of an interesting problem here. So it's almost like a working backwards. They did not give you the pre-image, they gave you the image. This is the image. So over here, you need to draw a preimage. Now, is this preimage bigger or smaller than the image? Well, the preimage was dilated by a scale factor of 3/4. 3/4 is less than 1. That means this is a reduction. So the image is a reduction of the original figure. So the original figure, the pre-image, should be a little bit bigger. Okay? And the idea is that if we were going to go from the pre-image to the image, the scale factor is 3/4. All right. Now, this is an area question. So immediately, let's just talk about the scale factor squared, which is 3/4 squared, which is 3 squared, 9, and 4 squared, which is 16. Right. This is the idea of what we're going to use. So the area of the image over the area of the pre-image is going to equal our scale factor squared of 9/16. And if we multiply both sides by the area of the pre-image, here's our formula, right? Area of the image is 9/16 times the area of the pre-image. Well, we want to find this. This is our unknown. We know the area of the image. We can find this area. It's a rectangle. Area is base times height. That's 9 times 6. That's 54. So the area of the image is 54 units squared. So what I'm going to do here is I'm going to put that in place of here. So not in that color. Let's use blue. So 54 equals 9/16 times the area of the preimage. Well, why am I going to solve this? Oh, and let's call that x. Let's not call that area of the preimage. Let's call that x. Well, I want to solve this for x. I want to find the area of the preimage. We'll simply multiply by the reciprocal of that scale factor, 16 over 9. 16 over 9. And that's what you're going to do in your calculator, because over here, they cancel, and x is all by itself. And I'm going to do 16 over 9 times 54. 16 divided by 9 times 54. And I got 96. 96 units squared is the area of the original figure. So when I take a look at this problem, right, you have to think backwards. You have to think backwards. There we go. Good deal. Okay, let's do one more problem similar to this. All right, so let's take a look here. So it says a rectangle with a perimeter of 65 units is the image of a rectangle that was dilated by a scale factor of 4. Find the perimeter of the preimage, the original rectangle, before its dilation. Round your answer to the nearest tenth. Now, in these problems, sometimes you're looking for the preimage, sometimes you're looking for the image. Now, I chose the preimage ones because I think they're more difficult, and I want to show you them, okay? So in this problem, a rectangle with a perimeter of 65 units is the image of a rectangle that was dilated by a scale factor of 4. So we had this original pre-image. We know nothing about it. We do know that it was dilated by a scale factor of 4 to make this enlarged image. And the perimeter of this image is 65. We want to go backwards and find the perimeter of the pre-image. Okay? Well, the ratio of the perimeters, so the perimeter of the image over the perimeter of the pre-image is going to equal the scale factor, which is just 4. So we're not doing scale factor squared, just the scale factor. So we're going to multiply both sides by the perimeter of the pre-image. They cancel. So the formula is the perimeter of the image is equal to 4 times the perimeter of the pre-image. We know the perimeter of the image, the final answer. We don't know the perimeter of the pre-image. So I'm going to come up here and I'm going to fill in things. So the perimeter of the image, so 65 equals 4 times, and since we don't know the perimeter of the pre-image, I'm going to call that x. To solve for x, we need to simply divide by 4. When I divide by 4, x comes out by itself, and I'm doing 65 divided by 4. And that comes out to be 16.25. Notice it's a smaller number because your preimage was a smaller figure. It says round to the nearest tenth, so the 2 is in the tenths place, so that 5 is going to round the 2 up to a 3. I know it ends nice, but they still want you to round, and that's 16.3 units. So again, when you read these problems, be careful of what you're supposed to find. Are you finding the preimage or the image? And use this formula, right? This formula right down here. Use it wisely. I'll put it in green. Right here. Use this formula. Oh, sorry, green. Use this formula wisely to help you solve. Okay, and then just make sure it makes sense, right? If we would have gotten a bigger number for the perimeter of the pre-image, you should have stopped and said, wait, this is weird. The image is bigger, it's supposed to be bigger. Why is the perimeter of the pre-image bigger? And then you could maybe readdress your issues from there. Okay, good luck on this homework. And there's one more video on edge elastic, and there's a couple word problems there, so go there next.